go out and we're going to map with RTK, and we're going to make it quick. So first we have to set up our Emlid equipment, which will include an RS2 Plus on a base and an RS3 on a rover. And then we'll set up our GCPs around the site, ground control points. Now that our base is set up, we've measured the height to the antenna. It's averaging a fix. We're going to go lay some GCPs around the site. That's what we're going to do now. Okay, so our base is set up, and then we have GCPs around the site we're going to map. Each corner. We would have a fifth one, but unfortunately we had one stolen yesterday, so we're 3D printing a fifth one. 4 should be good though. Now the next step is we're going to set up our drone to fly the route. Now we're making sure the drone is connected to our base, so it has RTK set up. The connection settings to the drone aren't changing. This remote is connected to the internet. The base has a connection using a little SIM card, so they're both connected to the internet. And then there's the details that you put on Emlid caster, which I'm using for them to connect to each other. And I think we got a police officer coming to say hi. All right, we're flying the ortho flight pretty quick now, which is just consisting of nadir images where the camera is facing straight down and it's just flying one route instead of an oblique where it does 2, and then the camera does different angles. Because nadir images process for an ortho better. I had some trouble getting going because I could not get my RTK on the M3E to connect to the Emlid RS2 base station. Turns out it wasn't because of the details put in, it was because of the internet connection of the RC controller. So the solution was to move, set up the Starlink with a better connection area after my phone hotspot wasn't quite working. When I connected the phone hotspot, it looked like it was going to connect, but long story short, stable internet to the RC controller allowed it to then connect to the network to get those incoming corrections, and we're moving. Okay, so the drone flights are pretty quick on orthos. We're already landed. We're going to put the drone away, then we're going to run around with the RS3 and collect our GCP ground points. It's Doug from the future. I didn't record screen on what you do with Emlid while you're actually out here, so we're going to jump ahead to screen recording back here, but pretty simple. So, in Emlid, you'll pull up Emlid Flow. You'll have 2 views that you're primarily in. You're either in Survey down here, or you're in Receivers. With Receivers, when you're setting up your base, you're going to be able to see your base and your rover. So in my case, the base, the RS2 Plus, you'll see it as a Bluetooth connection or a Wi-Fi connection. I'd recommend connecting through Bluetooth. You'll go in, you'll do configurations for your base. You'll put in that height that's measured from the bottom of the extension to the antenna from the ground, and then you'll add in that extension of the 0.15 meters. It'll do the difference then, and that's basically all you need to do to set up that base configuration. You will initially need to set up your equipment. It's one of the harder parts of, okay, do I have an in-trip input correction? If not, just off. In my case, I'm doing an output that's in-trip that's going to the rover. I'm communicating over Emlid caster to the rover corrections. And then I'm also doing an output via LoRa radio, lets you do 2, to the RS3 that's acting as my rover that will run around and record ground control points. So that's for setting up your equipment. And then the next point is for recording ground control points. So your ground control points are set up. You've got your RS3 connected on as your receiver, and then you'll go into survey. For setting up a survey, it's fairly easy, just the naming and making sure that you have your coordinate system set up. Then you'll run out, you'll go to each ground control point, center of the pole. The RS3 is nice because it can be tilted. But once it's over the point, you'll hit this plus button and just name the ground control point and hit save. And it's going to record those coordinates there. That's it. You'll run through each one, record them all, and that's all you need to do while you're out there. Okay, so now we've collected all of our ground control points, put away our Emlid equipment, breaking down Starlink, and heading back to base. Okay, so when you get back and you're processing, here's the workflow from there. You're going to go back to your list of your surveys, and you'll be able to export the list. I typically just do a CSV. It's a fairly small file. I'll email it to myself. Then I hop on the computer. So let's hop over there. And then on the computer, here's the process flow. So this is specifically for Pix4D Discovery or Mapper. It's going to be similar to some degree in the other systems, 3DF Zephyr accepts ground control points, but again, we're using Pix4D. So for the actual process, you're going to do your step one initial processing before you do anything with the ground control points. This is going to pull in all those camera images. Once it's complete, then we're going to import the ground control points. We're going to Project GCP MTP Manager. These won't be here. This is where your Excel sheet of ground control points that you exported from Emlid comes in. So you'll do import GCPs. It's going to ask you what coordinate system you want to use. I've been using WGS84. Then you'll import that Excel sheet. Again, it should be limited to just the GCP name, GCP1, 2, etc., and then the X, Y, and Z. And then the other thing is you want to make sure that when you import them, that you have the longitude, latitude, altitude. You have it right for X, Y, Z, not Y, X, Z. If you do it kind of switched up or on a different coordinate system, when you import your coordinates, Pix4D is going to give you an error. Basically, it's going to say, hey, the things that you're importing are nowhere near the geo tags on the images that you just put in. So a chance to find, if you made an error there, typically it will line up and then you'll see them right within your images. So once those are selected, you'll import them. I'm going to hit cancel because this has already been done. From here, the next point you're going to do, these have already been done again, but you're going to go through and you're going to have a blue circle. It's going to be further off than this initially, probably, but you're going to click the center of the GCP targets. And over time, as you click, you're going to see those coordinates reflect more accurately the center of that ground control point. This also brings up a good point of GCP locations when you're laying them out. You should have them in a clear, flat area, not too shady, not too sunny, and definitely not too foliage. I was still able to get 3 here that I could see in the images, but ideally, the more that you have GCPs and overlap, the better, because the more it can tie to this ground point, this anchor point. So you'll go through, select them, try and get 3 or 5. After a certain point, you don't see as much return in continuing to mark them. So it's not going to help you to just mark 100 of these in the center. You'll go through, click, 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 do it for each of them. And then another point is how many ground control points should you use? I've been guided that, hey, having around the corners and then one towards, a substantial spot or in the center, that can be a good practice. So that's it for marking it. Then after you've done that, you're going to re-optimize. This is basically going to take those GCPs and then tie it back into that the photos that you've done. And from here, you are pretty much good to continue on with your workflow. In the case of Pix4D, continuing to do the point cloud mesh and process and the DSN orthomosaic. And basically what you've done now is you've tied in your ground control points. It's now going to reflect your geotag. It's basically going to correct your ground control points. Those are going to be the new source of truth, and you're going to be able to see your source of error from those. So as long as your ground control points are accurate, you have a very accurate model now. And from here, you're good. You have ran GCP, and you're going to see that accuracy in your report on that degree of error is going to come down considerably. So again, some complicated might be wrong. I feel like to get this set up the first time is the hardest part. After that, you're pretty much just turning your equipment on and running through the steps. It's when you get little things like, oh, my RC controller wasn't connected. It kept saying converging. I thought it was going to work, and I must have checked that the details were put in there 80 times. It's things like that that are going to trip you up, but as soon as you kind of get them set up, you don't really need to change them. I'm repeating myself. But that's pretty much that. Same thing. You might run into things with putting those GCP coordinates into the import, and hey, why won't I accept this Excel file, and just working through things like that. This really changes the difference of your project. It's one thing to be able to plan something of this when it's going to be tied off, by a foot or so. But when you start thinking about how big a foot can be, and like if you're building a sidewalk and there's going to be a wall over here, you don't have a foot of wiggle room. So you really do need to get down to that couple inch, 3 centimeter accuracy to truly be able to use these for planning that we say that this can offer on avoiding the headaches. You don't want this to cause a headache. So that's the idea. The other cool thing with GCPs is taking stock pile measurements. One little pile of this amount multiplied times, 1,000, that's probably too dramatic, but anyway, for it to be off, you need to be accurate. It needs to be very accurate. So it's probably a good point if you were doing this job and you're going out, you're taking ground control points. You want to take it one step further. Walk out and take a point measurement of the top of this pile, and then you can check those points and check not only to your ground control points, but other kind of just like one-offs to check basically the math on everything. I'm still learning this. You can tell I'm talking out my ears a little bit, but I'm excited to start doing RTK. I'm excited to start having it work, and when it doesn't, for me to know what's gone wrong. And that's where you can start to offer these projects and these elevation maps that, they really are accurate and really are usable. That's it. I would almost say that's not it. I feel like I'm doing the quick run through of this because my last video was half an hour. I wanted to offer you a quick one. So if there's an interest, I can do a deeper dive. I'm learning. I might just do one anyway. All right. Take care.